Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to two-dimensional motion or motion in a plane. So in the previous videos we discussed some basic introductory concepts related to two-dimensional motion, and then in the previous video we discussed the representation of various displacement vectors and everything related to motion in a plane by resolving the individual components along the x and y axis. So in this video we are going to discuss the representation of the velocity vectors through the same principle. So motion in a plane with uniform acceleration. So this involves the velocity vectors, the representation of velocity vectors. So basic definition of acceleration we know, we have discussed it in the one-dimensional motion. The same applies for two-dimensional motion, but here two components are involved. So acceleration is simply change in velocity of an object divided by the time taken, or the time interval within which the change in velocity happens. So like we discussed uniform velocity in the previous video, so uniform acceleration is if an object or a body, it undergoes equal changes in its velocity in equal intervals of time, then it is called as uniform acceleration or constant acceleration. So let us try to depict this whole thing in a xy plane with the help of vectors. Let's say we have u vector and v vector, which represents the initial and final velocity. U vector is initial velocity, v vector is the final velocity of the object. So what we have done is, first we have resolved them, u vector and v vector, into their x and y components respectively. So u vector, it has the horizontal x component ux I cap and vertical component along the y axis uy j cap. Similarly, the final velocity v vector, it has the horizontal component vx I cap and the vertical component vy j cap. This vector, the blue vector, which joins the head of the initial velocity vector with the head of the final velocity vector, that is the change in velocity. So here we can write it as u vector plus delta v vector, that is change in velocity, that is equal to final velocity. Okay, that means v vector minus u vector, that is the change in velocity. Now we know acceleration is change in velocity by time taken. Let's say this change in velocity of delta v vector, it happens in t seconds or whatever duration t unit of time. So acceleration, change in velocity by time taken, that is final velocity minus initial velocity by t, that is t minus 0. So this is equal to v minus u by t, or we can write the final velocity is equal to u vector plus a vector t. So if you remember the first equation of motion, that is basically this. In one-dimensional motion, as in that no vectors were involved, we were not discussing it specifically as we did in two-dimensional motion, where we have to resolve them into individual components. Simply we used to write v is equal to u plus at. Final velocity is initial velocity plus product of acceleration and time. So same thing here is represented in the form of vectors. So now we know that every vector can be resolved into its horizontal and vertical components. So velocity is also resolved into its horizontal and vertical components. This is the initial velocity u vector, which is ux I cap plus uy j cap, which we discussed here, ux I cap, uy j cap, and the final velocity also vx I cap, vy j cap. So these are the two vector representations of the initial and final velocity vectors. So please keep that in mind. Similarly, acceleration is also a vector. So acceleration is also represented in terms of its initial and horizontal and vertical components, that is ax I cap plus ay j cap. This acceleration, a vector, this one. Okay, this will also have a horizontal and vertical component, which is represented by this. Now we have this equation, okay, first equation of motion, which is written in the form of vectors. V vector is u vector plus a vector t. Our objective here is the representation of velocity vectors. So here, let's say we write this equation, first equation of motion in the form of vectors. V vector is equal to u vector plus a vector t. Now we substitute each of these vectors with its respective rectangular components, that is horizontal and vertical x and y components respectively. So we write v vector as this, vx I cap plus vy j cap. We write u as ux I cap plus uy j cap. We write a vector as ax I cap plus ay j cap, and t is t, the time derivative. Now suppose we have written this equation. Now we have to bring all the coefficients of I cap together and all the coefficients of j cap together. Rearranging the equation, we will have something like this. Okay, this. Now what we have to do is we have to compare the respective coefficients of I cap and j cap on both LHS and RHS side. So Vx will be this, okay, and Vy will be this. Okay, so we have Vx, which is the component of the velocity vector along the x-axis. It is equal to, this is the final velocity. Always remember, v is the final velocity, the component of the final velocity vector along the x-axis. That is equal to ux plus axt. Ux is the component of the initial velocity vector along the x-axis plus ax, which is the component of the acceleration vector along the x-axis, plus t into t. Okay, that. Similarly, vy, which is the component of the final velocity vector along the y-axis, is equal to the respective initial velocity and acceleration components along the y-axis. That is uy plus product of the component of acceleration vector on the y-axis multiplied with t. So the basic objective in two-dimensional motion is to separate the x and y components. Okay, so the analysis of x components is done separately, and the analysis of y components is done separately. X and y components, they are treated separately. Yes, they make we combine them together to give us the resultant, but when we resolve them, when we separate them into their individual components according to the respective mutually perpendicular directions, okay, then it becomes easier to analyze. Okay, so that is the basic objective of this video, the representation of the velocity vector, okay, in terms of its x and y components. This is the final velocity vector. Okay, this. So same, you see, this is also the equation of motion, the first equation of motion. V is equal to u plus at. In one-dimensional motion, we used to simply write this because motion was happening only in one direction along a straight line, along a one particular axis. But here, motion is happening in a plane, so we have to consider its resultant individual components by resolving them into their individual components. So here we have to consider the x side also and the y side also, and in both the cases the essence of the formula, the essence of the equation of motion stays the same. V is equal to u plus at, but here the respective components along the particular axis that play a role. Final velocity along x-axis, initial velocity along x-axis, acceleration vector along x-axis. Similarly, final, initial and acceleration along y-axis. They contribute to this equation. Okay, so this is the representation of velocity vectors for motion of an object in a plane with uniform acceleration. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.